Well, hello everyone and welcome to today's webinar. We're going to cover array support structures. My name is Rob Rowell. I'm a senior engineer with Sunwise, and I have over 28 years of experience in the solar industry. And joining me today, as always, is Errol Rankin, who is going to be in the background helping us out with some questions and other stuff. And actually, Errol's going to help us with our online sizing tools for sizing the array support structures at the tail end of the webinar. So with that being said, let's go ahead and get started. As usual, please put your questions in the question box and then we'll try to address this as we go along, or certainly we'll cover those at the end. And also this webinar will be recorded. If we're going too quick or if you miss something, I take a call or whatever it is, you can always go back to the recorded webinar later on and catch that part that you missed or replay something that you didn't quite understand. Okay, so there's always available, and those will be online on our website, usually within 24 hours or less of this webinar. Okay, as usual, for those who are not familiar with Sunwise, just to give you a little background, Sunwise has got over 25 years of experience in off-grid systems, and we range everything from standalone to hybrids and battery backup and some other stuff in there as well, and I'll get into some of those in just a little more detail. We also do component orders, so if you know what you need and you just want to order parts from us, that's fine too. We can do that. We have manufacturing facilities on both coasts. We have one in Oregon and another one in New York. We've got sales offices throughout the United States, and as well as engineering offices also. Okay, again, as I mentioned, we can provide complete standalone systems, including some design help with those. We can do mobile systems, ones that are basically on a trailer. We can do hybrid systems. It can be solar wind or solar generator or your solar fuel cells. We've got all kinds of hybrids nowadays, to be honest, all kinds of additional sources to add to the PV. CDC, which is also a cycle charge, which is basically just a generator and a battery. Battery backup, of course, we can do several variations on those, AC or DC backups. We can also, all the stuff is pre-assembled and tested, QC'd. We can also build to ISO and standards as well as UL, and certain of the facilities have those ratings, not all of them. So if that's needed, we can do that. We can also do custom modules. As I mentioned, we can do component sales. So if you know what you want, you just want to buy the parts from us, that's fine too. We can also do sub-assembly. Sometimes we can just sell you a control panel if that's what you need, as well as contract manufacturing, other value-added services. And speaking of those other services, we can help with consultations up front, technical spec writing, design engineering, as I mentioned. We can do that separately or as part of a system. Systems integration, control panels I mentioned, we can use panel assemblies as needed. Site surveys, we can do installation services training, similar to what I'm doing now, but I could tailor it specifically to your needs if needed. And troubleshooting. Okay, so let's get into today's topic, again, which is array support structures. So this is what we're going to cover today. We're going to start with why are they important? So basically, what is the purpose of a mount? What should I look for? And why are they needed? Talk the types of mounts. Going to go into trackers a little bit, not to be confused with maximum power point trackers, which is it's an electronic controller that tracks the IV curve of the solar cells themselves. These trackers actually track the sun. They're actually physically tracking the sun. So we'll get into that in just a little bit. Talk about materials and finishes, wind loading and those ratings, array orientation, tilt angle, and then Errol's going to go into the online sizing tool, which will help you select the correct mount for your application. Okay, so what does a support structure or array mount do? It supports or holds the solar modules. It's a place to install the solar modules. It places it at the correct tilt angle, and it places it at the correct orientation. When I mean orientation, I mean facing south in the northern hemisphere or facing north in the summer hemisphere. You can use it can use either a ground or a pole for mounting. Okay. You can also obviously attach one to the roof of a building or other structure. Usually those are ground mounts that are modified. Okay. Also, you can the mount can also elevate the array, and again, pole mounts typically, almost by definition, are going to elevate the array, but you can also elevate ground mounts in certain ways. Elevating the array can help a lot. It can help minimize shading from objects like vegetation, fences, other obstructions. It can help reduce theft and vandalism. So you might need a ladder to get up to the modules. It can also shade other components underneath it. If you locate things correctly, you can have the solar modules act as a type of shade structure for your batteries to help keep them a little cooler in the summertime. Just a picture of a pole, large pole with a couple of mounts on it. I want to note that when you do this, when you stack solar modules, we're going to have a few photos of these, you need to make certain that you do your calculations correctly and there's adequate space. You'll see there's quite a bit of space between these two structures. You do not want the structure above shading the structure below. You can do it, but again, you need to make certain your calculations are correct and that this distance in between is set up such that there's no shading issues. Okay, so let's talk about the types of mounts. The three most common types, and there will be variations of these, are going to be a side of pole, which is where the array is literally mounted to the side of the pole, or top of pole, where it's mounted to the top of the pole, and a roof or ground mount. And again, generally it's the same structure, just modified. So generally the roof or ground mount. The roof or ground mount, again, can be attached to buildings or other structures. It can be elevated by using piers or a substructure. So there are various ways you could put some type of metal substructure underneath. You could pour concrete piers using sonotube. So there are various ways to elevate the ground mounts to get them above vegetation and other obstructions. Or they can also be trailer or skid mounted. Side of poles, typically you're going to find that for the smaller modules, they're going to range from about 5 watts to 600 watts. That would be, again, one very small module up to 4 of, say, like the 150 watt modules. Okay, that's how you get your 600. Or in the larger sizes, you can go from 250 watts. Again, that would be a single large format module up to about 900 watts. And that would be for 3 of the larger 300 watt modules. Okay, generally you're going to use a 2-inch to 8-inch Schedule 40 pole. The 8-inch would obviously be used for the 900 watt one. There's a lot of force against the pole bending momentum, so you would need to use that. Sometimes Schedule 80 poles can be used too, especially in these larger ones. On the 8-inch, you might find Schedule 80 pipe is used. It's got a thicker wall to it, again, so that'll help with the bending momentum and forces on that pole. Okay, the 2 inches are usually used for the smaller ones. And in this 5 watt, you might even find something even smaller than that, a 1 or 1.5 inch. Also, these can be adapted to Roan tower mounts. There are ways to adapt them for that as well. By the way, if you do, it's something that we hadn't really mentioned or thought about, but you can also do tower mounts, especially with the Roans. You can straddle across 2 of the legs. If you are doing that, again, you do not want to do it for the bigger ones. It puts too much pressure on the tower, but for the smaller modules, you can certainly do that. But again, you have to go across 2 of the legs, not 1, and even make certain that those 2 legs are aligned perfectly to south, which might be an issue. So something to keep in mind about that. I'll talk about that a little bit more when I talk about ground mounts. One of the problems with the ground mounts are just that when you pour that foundation, you need to make certain that it is properly aligned to south. Okay, the smaller ones, again, could be a single arm or a dual arm. I'll talk about that when I show some photos of those. Single arm is usually for the smaller ones up to about 65 watts. Generally above that, you need the dual arm, or also known as rails. It would be 2 rails. Okay, the dual arms also usually have additional support underneath it for multiple modules. We'll show some photos of those. So this is just an example of a single arm. It's just a single bracket attached to a pole, usually with a band clamp. U-bolts can also be used, by the way. Band clamps are a little bit easier, though, because they make it adjustable in case your pole diameter is not exactly correct. So the band clamps are a little nicer for that. But pole clamps are also acceptable. U-bolts. Here again is so this is the single arm that would get attached to that bracket. And usually these are pretty adjustable. You see there, this curve here is how you adjust it. That gives you quite a bit of flexibility there with regards to tilt angle. The other nice thing about this is because it's on a pole, you can spin it to face it south. You can just sink the pole into the ground and then spin the module around to line it up to south correctly. And then again, just adjust this arm up or down with this pivot point and then tighten that bolt there once you get the correct tilt angle. I'll talk a little bit more about that later, how to make certain you are aligned to south and how you make certain you get your correct tilt angle. It's with a very inexpensive tool. There's like a $5 tool out there to make sure you have the right tilt angle, and I highly recommend you have that in your toolbox if you don't already. We'll talk about that a little later on. And again, just some more photos. Again, notice here that when stacking these, and you can see here is the shadow and it is way above the module here. So again, when you do stack these, you want to make certain that you do not have an issue with shading from this module to the lower one. Here's an example of the 2 rails. This is a pretty big one. This is a 600 watt application. These are either 140 or 150 watt modules. You'll notice here you have 2 different legs coming back. The other nice thing about these are that uh, again, you can use either band clamps or U-bolts for these types. You'll also notice this is also being used on the battery box. It's mounted below it as well. And you have multiple ways to adjust these. You can either adjust these by taking these clamps here that are these brackets here that are attached to the pole and move them up or down. Or you can also have these legs here which go in and out. So you can adjust the tilt either with the legs or with spreading these things in and out. So it gives you quite almost infinitely adjustable when you think about it from that perspective. So it isn't like some of these other ones where you have specific like 5-degree or 10-degree increments. This is you can get down to 1 degree increments with regards to your tilt angle because of this adjustability. Usually the side of pole mounts are unique with that. You usually find that with these side of pole mounts. Top of pole mounts are usually a bit different. Usually they have pins in there, so you can usually work in like 5 or 10 degree increments. Which I just mentioned, here we go, easily adjustable again, because of those adjustments I just showed. Also, because you have a pole, they're easily elevated. As I mentioned before, you can just spin the module to fit, to either true south or true north, which is kind of nice about these things. You don't have to worry about having the civil works just right. You just spin it till you get the right angle, you get the right direction. And again, with these band clamps, and even if you want to swap out U-bolts, you can adapt it for larger poles up to 12 or 24-inch ones for the utility type, or for the the wooden telephone poles, basically. You could probably also use lag bolts as well in some of the smaller modules. We haven't talked about that much, but if you are using a wooden pole like a telephone pole, you could use lag bolts or even through bolts on those. As I mentioned, the array can provide structure for things underneath, specifically battery enclosures. They can also support other enclosures. As I mentioned, you can add battery enclosures on it. That is kind of limited to about 600 amps at 12 volts. What ends up happening is that once you start getting batteries that are too big, they start adding too much weight to the pole, and you end up having additional load issues with the pole with the weight, and also even on the band clamps or the U-bolts as well that are attaching the pole, and you start getting a problem with that. So there is kind of a limit to how much you can put on a pole that makes sense. Also, these enclosures as well, you don't want the bottoms of them to fall out. The enclosures themselves, not only do the mounting and the brackets have to hold it, but the bottom of the box and transferring that force through the back of the pole to the back of the structure enclosure into the pole also needs to be done. So again, there's kind of a useful limit there. But you can also mount load enclosures if you got radio equipment or something like that. You can mount the control boxes, combiner boxes. So it's kind of nice to be able to have a neat place to mount those things that get them off the ground, so that you can have it kind of at eye level or a nice height to be able to work on them and not have to be down in the dirt type of thing. So they're nice for that. Top of pole mount, very similar to the side of pole. So you can see a lot of the same stuff. Again, this you can get up to quite a bit more. You can get up to 12 of the larger 300 watt modules. You can get up to 3.6 kW pretty much. You can get quite a big array up there, quite a lot more than with the side of pole. Again, the 2-inch for the smaller ones, up to 8-inch for the bigger ones, and an 8-inch schedule 80 might be required if you have a high wind load, or if you have a tall pole. So again, you may even have to go to even bigger, depending upon the size, the wind load, and the how tall the pole is. Again, the higher the pole, actually, the more wind load on it. So you'll keep that in mind as well. So that's something else to consider when working with these. Again, they're also easy to align to true south or north, same as with the side of pole for the same exact reason, just spin it around. These can come in fixed or adjustable tilts. Sometimes that's an option with these. If you have a high quantity, you could just get a fixed tilt. And otherwise, they're adjustable. So usually there's kind of a pin in there or a bolt that goes through in either 5 or 10 degree increments. And generally they're adjustable somewhere between 0 to 60 degrees or sometimes even just 10 or 15 to 60 degrees. So let's see with those. Again, all that same with the side of pole. And again, they're also easily elevated because you have the pole there. Okay, also same as with the side of pole, you have they can shade the battery enclosure and other electronics underneath. And again, you can attach all the same stuff to the pole, same as the side of pole, same limitations kind of on the battery box. And just some more examples of top of pole we got here. This one actually has some reinforcing in the front to help with the wind load on it. So this is what they call a high wind version. You can see here's a battery enclosure attached to the back of it. Here's another one at what seems to be a very low tilt angle, probably about 10 or 15 degrees. And just another example of a top of pole. You can see here you got like a little combiner box or something attached to the pole underneath it. Okay, ground to roof mount. Again, nice thing is they can fit any size solar array. This is why most commercial applications, when you see these large solar fields, are all using some type of ground mount type of structure because you can just add on to it. The problem with this, though, is that because of the civil works involved, it needs to be installed facing true north and true south. So when somebody actually pours the concrete, you want to make certain that this is properly aligned, and we'll talk about that again a little bit later. Again, it can be adjustable or fixed tilt on these. Sometimes the fixed tilt is used more in the high wind applications because you don't have to worry about the possibility of just because the forces with some of these adjustable ones, depending upon how they work, there may be an issue with the wind loading on them. So if you get in the really high winds, you might find the fix is a little bit easier to do. And here's a photo of a ground mount. Again, this is a 4-module one. These are actually 72 cell modules, it looks like. So these are, again, probably either 140 or 150 watt. And again, you can see us talking about here with the pad or the civil works underneath that had to be properly aligned to face south. So that's just something to keep in mind when working on that. And just kind of an example how these two go together. Again, with these, you're still going to have 2 rails and you still have 2 legs, and you're going to have some feet that go with them, and these feet are attached to either, in this case, you're showing a slab. It doesn't have to be a slab, though. You could install these on concrete piers, as I mentioned before, which you could pour with sonotube. They could also be attached to some other type of metal substructure, or you could even just do footings. I've seen them pour footings in the front and footings in the back. And the footing in the back is usually like 2 or 3 or even 4 times as big as the footing in the front because of the wind load on the back of it. All the wind load's on the back, so they'll pour more concrete there sometimes. So there's a few variations on this. We are not civil engineers here, so I would recommend you consult with a civil engineer with regards to your requirements for that, with regards to the wind load, soil conditions, and other things in your location with regards to that. Here's an example of the one I kept mentioning, the concrete piers. Here's a great example. You can see the concrete piers right underneath this. So you can see these feet coming down and attaching to the piers. You have multiple piers, and that's a way to take your ground mount structure and make it elevated. Don't know the height on this, but I'm going to say it looks like at least it gets 6 feet, maybe even 8, because it's higher than the fence. The nice thing about this is helps with vandalism and also helps get it above the fence line, so you don't have any shading issues with the fence. Very nice for that. As I mentioned, you can also mount them to a skid or a trailer, so they can make them mobile as well. Okay, I mentioned trackers early on. We're going to talk about those in a little more detail. They're defined, a solar tracker is defined as a device that orients a payload, in this case, the solar modules, toward the sun. Okay, for a flat panel, the idea is that it minimizes the angle of incident between oncoming sunlight and the PV panel. Essentially what it does is it just tries to align your solar module to the sun as much as possible throughout the day. Okay, there are active and passive ones. I'm going to talk more about the passive ones. We'll talk about both here actually, but unfortunately I don't have as many slides on the passive, but I'll just talk more about that verbally when we get to that slide. Active trackers, you can get those in both single and dual. Single is the most common, and again, these things are generally for large commercial systems. I don't want to spend a lot of time on this because we don't normally use them in off-grid, and I'm going to talk about why we don't use them off-grid, but I just want to make you aware of these things. And again, this is not the same thing as a maximum power point tracker. This is a active structure tracker, which is again different. This is mechanically moving the solar modules to see the sun, as opposed to something that is actually electronically changing the IV curve of the IV curve of the module itself. Okay. Now, with the single ones, you need to actually align these on the north-south north-south axis, so that generally rotates east to west. So generally, you're going to see it face east in the morning and then west at the end for sunset. They can also be vertical alignment, but generally you're going to see these mostly on a north-south axis, so that you're rotating east to west. You can also tilt that too. I've seen that before as well, where they put a slight tilt on them, usually on the bigger ones, usually on smaller ones, but that's an option as well. Don't see too many as much anymore. Again, we don't even see the active trackers or trackers at all much anymore. I'll talk about that why later. Just want to make you aware of the fact that they do exist. They were very common a couple decades ago, but they're not anymore, and for some obvious reasons I want to point out. Again, as I mentioned, they usually rotate horizontally with respect to ground. They're usually mounted flat, and then again, they're usually going to go east-west. Again, this is on the horizontal single-axis tracker. Yeah, kind of mentioned all this stuff already. And here's an example. And again, this is a large commercial field type installation, not something normally used in off-grid. Okay, vertical axis, very similar, kind of same concept with that. And again, usually you're going to use a tube for that one of some form. Let's see, not very common though. Tilted single axis, same thing with that. Rotate between the horizontal. Let's see. This can sometimes be used to reduce the wind load profile. But anyway, again, I'll get into why we don't usually do these things too much. I think we already covered some of this stuff already. Okay, let's get into passive a little bit. Here's an example of a passive. Passive trackers are almost always mounted on a tube. They're generally dual axis, but they can also be single axis as well. And the way they kind of work is, the way they're passive is the active ones actually, didn't really get into detail, but the active ones have to have some controls and electronics. Basically, you tell it where the longitude and latitude is and the time of day and year. So you have to tell it, you have to kind of give it a real-time clock and a calendar, and you have to tell it where you are very specifically, and then it knows where the sun is. There's a whole bunch of calculations, trigonometry calculations actually, sine and cosine, to tell you where the sun is in the sky, and then it's going to move the solar array to follow the sun across the sky. So you need a couple of things there. You need a very smart controller that you have to program to tell it where it is, and then you're going to have gears and some type of motor device to move the solar array around to follow the sun. Okay, the passive trackers don't have any electronics in them. What they do is they have these. You can see in this photo, you've got a black kind of rail on one side of the solar array and another black rail on the other. What they have in there is they have a material that expands when exposed to sunlight. Okay, and that can be some type of wax or freon or something like that. Basically, it's a material that expands, and then what happens is when that material expands, it actually pushes on pistons. You can actually see a piston here, and I think there's another one here. And when those pistons move, it then moves the solar array east to west and north to south to follow the sun. Now the issue with the nice thing with the passive trackers is you don't have to worry about any electronics or any of the programming associated with that. The negative is that it only works in direct sunlight. If it's cloudy out, it doesn't know where the sun is. So that can be a problem. It's also slow to wake up in the morning. So the sun could be, a quarter of the way, a third of the way across the sky before this thing actually figures out where it is. So again, a couple of negatives to it that have been issues with these. So just keep that in mind when working with these. Again, you have an issue with what we call wake up in the morning, and that they will not work on a cloudy day because it does not know where the sun is. The worst thing is that if it goes back, and then what will happen is at the end of the day, it'll actually get stuck facing west. And if you've got a cloudy day and it doesn't wake up and go back east to start over again, then you're going to be losing a lot of sunlight. So that's one of the negatives of these things is with the passives like this. So something to keep in mind with working with them. Okay. Active trackers, again, with the singles, they can get you up to 30% additional sunlight by doing that. So this sounds like a really great idea to some extent, but I'll tell you why they're not that great. And the dual axis can get you another 10 or 20% on top of that. So you can get somewhere around the 40 to 45% with the dual axis trackers, which sounds like a great idea, except for the negatives, which we're going to point out. In this case, one of the reasons you don't want to do it. First off, they're quite expensive, okay, for those things. And solar modules have gotten so inexpensive, it's actually cheaper to add more solar modules than it is to trackers. So that's probably the number one thing that has made trackers kind of go away. Is just that they were common 2 decades ago when solar modules were $4 a watt, but now you can get some of these for as little as $1 a watt. All of a sudden, the cost of those trackers no longer makes sense because these trackers could cost well in excess of $1 per watt. So you're spending more for the tracker than you are for the solar modules. So at that point, it just makes sense just to add more solar modules. So think about this. It's going to cost you twice as much for the tracker, and you're only going to get at best 50% back. It's kind of a losing proposition. So that's why you don't see those too much anymore. Okay, that's one. Number two is, again, because you have all these mechanical moving parts, you have all these, even whether it's the pistons on the passive tracker or whether it's all these gears and motors on the active ones, you have all these mechanical parts. They require maintenance, they require servicing, and they are a point of failure. So these are all the reasons you would do that. Again, because of all these moving parts, they're actually not good for high wind loads as well. Makes it an issue. So these are all the reasons why you do not want to use it and why you don't hear those much anymore, why you don't even see them much anymore, although on these large commercial applications. So anyway, so again, the advantages of non-tracking ones are they're simpler, lower cost, and just easier to work with. No maintenance on those things, pretty much, other than just check and make sure the bolts are tight. And if you have a pull mount, that it's still facing south correctly, and that just basic simple maintenance, really. Okay, let's get into wind speeds just a little bit. Let's see, wind speed ratings are basically directly related to the square footage of the array. Basically, you put a kite up on a pole, essentially. So the bigger the kite, the more wind load. So you notice that when we rate our structures, they're rated based upon square footage. So you need to calculate the module you have into square footage. So as an example, here are some of the tables you can see. We've got here maximum module area per square feet, 10 square feet for these structures. And we'll get into that. Again, we have data sheets on our website for all of our structures. You can see all that. And also for the modules, you can calculate it manually. Or if you don't want to waste your time with that, Arrow is going to tell you how you can just go ahead and click on our online tool, and it will take care of all that for you. You don't have to think about it. So we'll talk about that at the tail end of this webinar. Okay, let's talk about a little bit about materials and finishes. Structures are typically fabricated from aluminum or steel. Okay, the aluminum structures can be left bare, or they can also be finished for corrosion protection. Generally going to find anodized, painted, or powder coated. I think probably the powder coated is the most common. You don't really see painted too much anymore. Anodizing actually is not any better than the powder coating in terms of protection. Usually costs a little bit more money, so you'll find the powder coating most common when it comes to that. Okay, when working with steel structures, they have to be protected or they will rust. So you absolutely have to do that. Hot dip galvanizing is probably one of the better options, but powder coating and painted are also okay. The hot dip galvanizing, again, is a little bit better because if they get scratched, the zinc can actually migrate a little bit. So that's kind of what they call a self-healing property to it. So if it gets scratched, it can kind of the rust that forms from that won't be as bad as the painted or powder coated. These are also a bit easier to damage than the galvanization as well. So although they're cheaper process, that's the reason that you'll see a lot of the painted steel as opposed to hot dip galvanized, just because it's cheaper to do. Fasteners can be zinc plated steel or they can be stainless. Obviously the stainless is better for corrosion. The zinc, if it gets scratched or whatever, again, it has a more potential to rust than for the stainless steel. I want to point out though, stainless steel can rust, despite its name. It can rust, and there are grades and levels of stainless steel. The most common are 18.8, 304, and 316. 316 being the best. This is what you would usually use in a marine environment. You'll find this used on boats and offshore platforms and stuff like that. And even they in those environments can still have corrosion. It'll take many years to get there, but I just want to point out there are grades to it. So when you ask for stainless steel, you could be getting one of the cheaper levels and not one of the higher ones. It just depends. And by the way, there are other levels in here too I did not mention. There's a few other kinds. So I just want to put the most common in there. For fun, I think for fun, you can actually look at if you have flatware at home. Take a look at it. Usually they're stamped on the back. I think the most common flatware is actually 18.8. So if you have stainless steel knives and forks you use at home just for fun, see what the rating is on it. Like I said, generally they're stamped as 18.8, which is not as high levels as the other ones, simply because you don't necessarily need it. Your dishwasher is not going to have salt in it, so you don't have to worry about corrosion like you would on a marine environment on the ocean. Let's talk about continuing with the fasteners a little bit. Um, One of the things to help fasteners from loosening up, you generally want to use either lock washers or lock nuts of some form. Nylocs are pretty common, but there are other variations of lock nuts as well. But at least lock washers, they can either be spring type or star type, or there's a couple of different variations on that. But again, you want some type of locking device on there, whether it be a nut or that, or even Loctite is an option too if you want to go with that. The problem with Loctite is that it makes it more difficult to remove stuff later, and or uh, um, with that, or if you do remove stuff later, you need to make certain you reapply it again. So, but that is an option as well. Anti-seize is highly recommended when working with stainless steel hardware. Unfortunately, stainless steel has this thing called galling, where if you try to spin it on too quickly, or if you try to put the hardware on too quickly, it will actually seize up and lock onto the bolt. Not a common thing, but it can happen. It happens enough. It can be very annoying in the field. So if you put a little bit of anti-seize onto your bolt, onto the threads before you put the hardware on, before you put the nut on, it'll help prevent this galling. And when it does gall, it is a real pain in the neck. Sometimes you have to hacksaw the bolt off and start over again. You really don't want that happening. So, and again, it's just one of these weird things about stainless steel, where when you do that, these threads kind of lock up and they seize on you. Literally, they kind of almost kind of weld themselves together. I'm not a chemical or mechanical engineer, so I can't really tell you how that works. I just know it has. I've experienced it. It is not fun. Again, you end up having to cut the bolt off and start over again. So if you're lucky to have room to cut the bolt off, if you don't, you have to try to actually break it off yourself and tear it apart, shear it, which is also not easy. So again, using the anti-seize on there is an easy way to prevent that from happening. Okay, let's talk about wind loading a little bit more. Structures usually rated 90 miles, 110, or 130 miles per hour. 90 is kind of on the low end, so I think I almost can't think of a structure not rated for 90. And again, this is just a structure, by the way. It's not the foundation using a ground mount, and it's not the pole. So you need to have a civil engineer, tell you what size pole you might need, or how far into the ground that pole has to go, how much concrete you have to put in the ground, all of these things to get that wind load rating. This is just the structure itself, okay? And again, 130 is at the high end. I kind of put these slides a little bit out of order. The reason the 130 is the high end is because modules only rated the 130 miles per hour. Literally what happens is, I've seen this happen in hurricanes before, I've seen the aftermath of it. Literally what will happen is once you go greater than 130, we have people in hurricane zones ask for 150 miles per hour, and I always laugh. I go, it doesn't make any sense, because what literally happen is the glass of the modules literally implodes and blows out of the frame. So what you'll find is when you get back to your after a hurricane that is, category 3 or 4, has exceeded 130 miles an hour, when you get back to look at it, you will find that you will have your module frames and your structure there, and your glass in your module is gone, wire and all. I have no idea what happens to the wire, but it just gets ripped off too in that force. So yeah, so no reason to really do more than 130, because you will have no glass, no modules left anyway. So I always laugh about that when people ask for 150 and they insist on 150, and I'm like going, fine, we'll do it, but it's a total waste of money, because again, the modules will blow out after 130 miles per hour. I just mentioned the California Building Code. It's actually forcing a lot of the structures to be a certain rating, 90 to 110 miles per hour exposure category C. I think the 110 is the most common now. So I think actually most structures have now gone from a 90 mile to 110 now, so they can meet this California Building Code. So just wanted to point that out. Okay, I mentioned we're going to talk about orientation. As I've been saying before, in an off-grid application and a stationary structure, you always want the array to face south in the northern hemisphere and north in the southern hemisphere. I cannot state that enough. You want it to face true south. I've had other people tell me, hey, I want to capture the western sun because I'm going to get more. You don't, okay? You don't. Unless you've got something shading it in a specific direction, in which case, yeah, you might want to move it a little bit. My advice would be to eliminate the shading problem if you can. But other than that, there is absolutely no reason not to face it true south. It should always be that way, okay? And you should use a compass to make certain that it's facing true south. If you're using a magnetic compass, keep in mind that there's something called magnetic declination, and that you should adjust for that. We'll talk about declination just in a couple more slides coming up here in a minute. Okay, so again, when it comes to the compass, you can use either magnetic or electronic. An electronic one might be like a GPS. GPSs have got compass in them. When using the electronic compasses, though, you can also, by the way, your phones also have it. I've seen a lot now. A lot of people have smartphones with the compass application. However, be careful with the free ones. And I'm not going to recommend any at this point, but I just want to point out that some of them may not be that accurate. Just be aware of that. I've seen some of them be off by more than 10 or 20 degrees, and that can be a problem. I also want to mention that in most cases, if you're off by about as much as 10 degrees, it doesn't really matter. So you could be plus or minus 10 degrees, and it's really not going to make much of a difference. But if you start getting off by 20, 30, 40 degrees, especially 30 and 40 or more, you're going to really diminish your output quite a bit. So plus or minus 10, not a big deal. Once you start getting past that, it starts to become a problem. And the further away from that you get, it's actually kind of an exponential type of thing because of the trigonometry of the sun. So when you're off by 40 degrees, you've actually lowered the output of the array by as much as 30%, whereas if you're off by 10, it's like 2%. So you can see it kind of grows rather quickly with that. So again, if you've got a compass that has an error of 20%, getting back to the declination problem, or something that is not calibrated very well, then that could be a problem. So again, you want to make certain your compass is calibrated, or you've confirmed that it is accurate in some way. Okay, just some examples of some compasses, some magnetic ones, probably ones you play with as a kid or something like that. Okay, here's a declination map for you. And by the way, these do change. The declination shifts by somewhere between 0.5 to 1% per year. And I don't want to get into the details or geek out too much on this stuff, but this is a natural thing that happens with the Earth. And actually, every several 100,000 plus years, I forget what it is, the poles on the Earth actually reverse polarity. So these declination actually continues to shift until literally the north becomes the south becomes the north. The poles actually reverse directions. And actually, geologists can actually use these to actually date things, by the way, because this reversing of the poles actually realigns the iron in rocks. So when you get a rock, you can actually rock with iron, you can actually split it open, and you can actually see the alignment of the iron flip directions every so many, hundreds of thousands of years, whatever it is, however many millennia it is, because of this principle. And actually, they're saying we're getting close to this again. They don't exactly know what's going to happen or how long the process takes, but we're actually getting very close to that again. And one of the ways you can tell is by how much we're shifting on this declination. So this does shift. And you can see that if you are kind of in the extremes of the U.S. here, whether you're up in Washington State or Maine, you can see that you are off by 20 degrees, as I mentioned before. If you're more central around the Mississippi, you don't have to worry about it much because you're pretty much right on. Here's an example here where we're going through kind of the New Mexico, pretty much Four Corners region, through maybe Tucson, Phoenix area of Arizona, and here you're off by 12 degrees. What that means is it means that even though your compass is off, true north is actually 12 degrees to the east of that. Okay, so that's what this map is showing. So again, if you're kind of in the central U.S., not really a problem, but if you start looking on both the East Coast and the West Coast, you have to compensate for this if you're using a magnetic compass. If you're using an electronic one, that's not an issue. You have to think about it, but just be careful that you have an accurate electronic one. That's all. Like I said, I've seen them be off by quite a bit. One thing about magnetic compass, of course, is don't use it near steel. If you're using it near oil pipelines or near railroad tracks, that steel will also throw it off. So that's something else to consider. There might be a case where you might want to use electronic instead of magnetic, so you have to think about that. Okay, let's talk about tilt angle now, the other property here with regards to trying to maximize the output out of your solar modules. Okay, so the array tilt angle should be adjusted to maximize the insulation. I want to make this very clear. For the month with the lowest available insulation, this is for off-grid systems. Okay, this is where the solar is the only charging source. If you're in a hybrid system or if you're in a grid tie system, it's a different application. Okay, you're going to want to align that to maximize the energy throughout the year for an average, an annual average throughout the year. We're not worried about that. We're worried about the month with the lowest insolation. We want to maximize that, okay, for off-grid. So in order to maximize that, typically that's going to be the latitude plus 15 degrees. So typically your latitude is your tilt is going to be latitude plus 15. And for most of the United States in the southern part, like around through Arizona, Texas, Florida, that type of stuff, you're about 45 degrees. When you start getting a little bit farther north through the middle of the U.S., 55 degrees, and sometimes up to the extremes, again, going back to Maine and Washington, you might be more in the 60-degree range, okay? Now, how do you measure? So if you can use a compass to measure south, then how do you measure your angle, your tilt angle? Well, that's a device called an inclinometer. Pretty simple device, actually. And again, it's a device that measures angle specifically that's tilting on the solar array. And you can kind of see here, these are two common ones. What you have is you have like this pendulum here, and it just swings around. You put this base here, and these can actually be magnetic, which is really cool if you're working with steel. You can actually just stick it to the rails or something like that. If you don't, I usually just put it on the top of the glass of the module, just kind of rest it on there. And this little pendulum will swing because this base here would be in an angle, and the pendulum actually works on gravity. It just will swing around. So you hit it. You can see this one here specifically is made up for 45 degrees because it's pretty common for the US for the tilt angle of the solar array. So it literally just swings. These are cheap devices, by the way. They range from like $5 to $10. I highly recommend when they're cheap. You can get them at Home Depot or Lowe's or your Sears Craftsman store, whatever. You can get these things. You can get them off of Amazon. Again, they're real common to get, real inexpensive. Highly recommend it for making certain you have set your solar array at the right tilt angle. Yeah, we just said all that. Okay, never mind. Okay, at this point, let me hand it off to Errol, who will talk about the online sizing tool.
Thanks, Rob. Appreciate it. Great content so far. I do want to mention one thing really quick before I get into the online sizing tools. You mentioned the civil engineering aspect of the mounting structure, and we did have a question on the chat about the embedment and the foundational concrete on that as well. I checked briefly some of our installation manuals. And I didn't see the fill details or the concrete volume details for the foundation guidance provided, but I feel like I've seen that before. And so if you're a person that would be interested in that information or would find that helpful, you can feel free to send us an email and we can potentially track down some information on that side of things. Even though it's a little bit outside of our scope, I think we do have some information on that.
There are some guidelines, and there are some general guidelines that you can use with that. Yeah, stuff like for every foot out of the ground, there should be like a third of it in the ground type of thing. So if you got a 10-foot pole, 15 feet. Well, if you have a 15-foot, basically a 15-foot pole, 5 feet should be in the ground, 10 feet be out. That's just like a general rule. Same with regards to how much concrete should be in the ground and stuff like that. These are all general rules. However, I want to emphasize again their generalities, and that you may want to consult the civil works based upon your soil conditions and the wind load and your location, things like that. Again, these just kind of give you a general guideline. Maybe you're perhaps getting estimates, but you should consult a civil engineer again for your specific requirements, just because you don't want the thing to blow out of the ground or flip over or whatever the case might be.
Absolutely. Thank you, Rob. That's all absolutely true. On the second point, with regards to the pole specifically, and there was also a question briefly on this, my understanding is that the engineering calculations or the engineering stamps that Sunwise has had performed on our mounting structures does include the structural analysis for the pole up to the Schedule 40 pole diameter sizes that we reference on our literature. So what that means is that if you use one of our single module double arm mounts, our 7954, and you're using that on a 2-inch to a 4-inch Schedule 40 diameter pipe, as we've recommended, then that structure from the array and the module and the pole will all be rated for 110 miles per hour. So if you use our Schedule 40 diameter pole size references for the various mount sizes that we've used, then the structural analysis portion should be accounted for within those design limitations.
Now, Errol, that should also be to a specific height as well, by the way. You can't put these things 20 feet in the air and still have that rating. So I just want to also mention that too. I don't know what the standard height is on those. I don't know what they were calculated to. I just want to point that out, that there is a specific height to that.
Well, actually, it's an interesting question, Rob, because we're hitting on all the various points of the series of questions that Peter had. And correct me if I'm wrong here, Rob, but my understanding of the exposure categories is that it's based on the type of geometries that you have on the terrain and the estimate of the roughness for that. Now, if you increase the height of the array, obviously the wind speed increases with wind shear, and there are common formulas to estimate that. But
and what's worse is that that's not linear. There's actually exponential. That's the problem. So
not linear in the slightest.
Yeah,
not linear in the
exactly. So it
slightest.
makes it even worse. So every foot higher
Right.
you get, the wind load is like 3 times that or something like it.
Yes. However, if you were to either use an estimate or put up an anemometer and actually get the data, but if you feel confident that the wind speed at X height is X miles per hour, or really it's the 6-second gust per the standards, then as long as your wind speed gusts at a specific height are less than 110 miles an hour, you should be okay. Ascertaining what the estimated wind speeds at a given height are will probably be quite challenging. And so for our assumptions and purposes, I would say anything less than probably 15 feet off the ground, I think would be within the scope of the ASCE standards and the diagrams they give. We reference the standard if you really want to dig in, but I think that's a general guideline. 15 to 20 feet would probably be okay.
Actually, I think generally a 10-foot pole is pretty normal for side of pole mount, and for the top of pole mounts, I seem to be as low as a 6 foot, by the way, especially when you get those really large ones
Mm-hmm.
we're talking about with
Mm-hmm.
the 3.6 kW. You try
Mm-hmm.
to do that on a 10-foot pole, and you've got a much bigger issue. That's where you start to get to the Schedule 80. You have to get to a thicker wall to handle the extra force generally at that point.
Okay, good. Yeah, so I just wanted to give a little bit more background on that. Okay, so back to the design tools. So first of all, I want to clarify kind of what the scope of the intent for this design tool is. So first of all, the design tool is for the scope of small format 36 cell modules. And is designed for the ecosystem of Sunwise racking products. So that's basically the side of pole, top of pole, large format, roof, ground mount. We offer a variety of series of mounts. Now, with regards to large format mounts, typically the sizing is a little bit more straightforward because everything is done at the discrete module size. So the mount will either be a 1 module, a 2 module, all the way up to an 8, 10, or 12 module for the top of pole, and that module quantity will be based on the format of that solar module, whether it's a large format, small format, or whatever the dimensions are. Where the sizing becomes a little bit more challenging is when you have to account for things like bolt hole patterns, rail length, square footage of the solar array, and whether the square footage of the particular module that you've chosen in the particular configuration will meet the max square footage requirements of various mounts, and will they also fit on the bolt hole patterns. So to assist in that process of sizing and selecting the right mount based on your array configuration, we've developed this online sizing tool, which does all those considerations for you. So to get to this on our website, you just go under the Build a System dropdown. Under the Select Parts, there's the Module Mount Selection tool. If anybody's at a computer, you can feel free to hop on over to that and run some tests really quickly as well. And I'll probably do a screen share here in a moment as well. Okay, next slide, Rob. All right, so as I've mentioned, the goal of this is to determine the correct mount part number to use for your specific application really easily. We've got a built-in module database of all of the 36 cell small format modules that we utilize and that we sell. That includes a variety of product lines and sizes all the way from 5 to 150 watts. At 12 and 24 volt module rating, as well as, whether or not it has some other factors like listings and stuff like that. These mount product lines support 1 to 6 module configurations in a variety of formats, including side of pole, top pole, roof, ground mount. And it's obviously integrated directly with our web store. So once you find the product that you need, it makes it easy to move forward at that point. All right. So this is basically the mount sizing tool, really pretty simple, just a series of button selections. So the first criteria that you're going to need to define is what sort of mounting type you have. If you already know that it's going to be a roof ground mount or a side of pole, or maybe you just know that it's going to be pole mounted and it could be side of pole or top of pole. Obviously, we have our pole diameter. Now, keep in mind that the pole diameter requirements go up with the array size for the corresponding structural support requirements. So if we were to choose the largest mount configuration with a 2-inch schedule diameter pipe, the tool might tell you that we don't have an applicable solution. And that's the idea of the tool, is that if there's an applicable product, it takes you to the right one. If there's not, it tells you so. And then we simply define the module characteristics in order to find the right module database dropdown. There's quite a few modules out there, as folks that have used various online sizing tools that include module databases. That could be charge controller, sizing tools, or other mount selection tools. It can be challenging keeping track of a module database because of the overwhelming number of module selections that are out there. So to help keep that a little bit more limited, it does ask you to select whether you're looking for instance C1D2 rated modules or 12 or 24 volt modules. So you kind of have to know a little bit what module you're going to be using specifically so that we can help the tool drill down into the rules that we need. And then, of course, we have the module quantity at the bottom. Once you make those selections, you hit the go button, and it'll redirect you straight to our web store to find the appropriate product. So I'm actually going to switch over here.
Okay. Can you add your need to give you control?
I think I can make myself presenter.
Yep, you did. Okay.
So can you see my screen all right, Rob?
Yep, you're there. We're good.
Okay, so like I said, under here, build system, it's the select parts, module mount selection tool. So let's say that I want 240 watt modules on a side of pole mount. So I'm going to select C1D2 rated because I like these really popular SPM 140s. And I'm going to go with a 2 module configuration side of pole, 2-inch schedule 40 diameter pipe. Hit the go button, and it redirects me to the web store for the side of pole mount 53-inch, 2 to 4-inch pole. We know this will support the 2 module configuration we just selected. Really, really simple and easy. It's just designed to help our customers save themselves time. Our employees internally use this tool all the time. It's really helpful if you just want to instantly know, is something going to work? Am I getting the right product for the right configuration? Am I getting the optimal product for the right configuration? Am I getting the smallest, most affordable, structurally sound mount that I can for this application? So it's a really nice tool. It works really fast. Give a couple other examples while I wait for some questions here. Let's assume we want to do a single 40 watt, 1 module. 7985 instead of the 7954. So you can see previously we got the double arm, now we get the single arm because we have a small enough module. We do have a question here on considering multiple configurations, like top of pole and side of same pole. For that, basically what you'd need to do is you would have to select the same, or it'd be 2 parts to it. You would have to select the same schedule 40 diameter selection in both array cases and make sure that you can choose the same diameter for both your different mounting array options. And then the second part was you would have to basically do your own shading analysis to make sure that they're spaced vertically far enough apart from each other. Rob, I was curious when you mentioned that earlier, is there a rule of thumb or a guideline on that vertical spacing?
No, because it really depends on your latitude. And believe it or not, it really does. And actually, as it turns out, the worst situation is actually the summer, not the winter, because that's when the sun's mostly overhead. So when I see people get it wrong, the systems fail in the summertime, people are completely perplexed by that. And that's because, again, it's so it's actually the further south you go, and in the summertime is the worst case scenario, which is kind of odd to think about it that way, because again, that's when your shading is worse. That's when the sun is more overhead. But no, it really does. It depends. It's still location specific. There's really not a good general rule of thumb for that one. And also depends on, again, how far out the solar module is sticking out there. So it depends on whether it's a 1 or 2 module structure, how big the solar module is. There's quite a few formulas that go into that. One of the things we've been
Mhm.
talking about and considering, though, is trying to come up with an easy shading analysis tool. I think Errol and I have talked about that before. Might be something I might be
Mhm.
considering in the future, but we're still kicking that one around. But yeah, because it's not easy calculations to do, and the vertical is even more difficult than the horizontal when working with those for
Mhm.
shading.
If it's a significant project consideration or it's something that you'd want to have looked at, those are the sort of things that we can potentially assist with. Never hurts to ask. Are there any other questions? We've only got about 5 minutes left. I'll certainly give folks a minute or two to ponder if they have any other thoughts that they'd like to get in or anything else.
Let's see. I think our next, we're waiting on that. Oh, do you get a question?
I do. He's wondering about where you can select the schedule of the poll in the chart, and I believe
It's they're all Schedule 40. There is not an option. They're all Schedule 40.
I see. Yes, he's wondering about the schedule itself. Yeah, so we're just defining the diameter here.
Yeah.
All of our calculations are based around Schedule 40
Schedule 40.
assumptions.
Yeah, Schedule 80 comes up when you get into the very large top-up pole mounts. And generally, we don't have those as a Sunwise option. We usually buy those from a third party, to be honest, about that one. And then, like I said, it's in the very large formats with 130 mile an hour wind load or something like that. Is where you get into the Schedule 80 poles. But again, that's not in our tool because our tool does not go to that big.
Mm-hmm. Yeah. You know what? There's actually one other question that we had from earlier from Peter Martin. It's an interesting question that I have not had experience with myself. Rob, when we were looking at that first photo on our presentation for the double array on the cell tower with the boom truck that was up installing them, are you aware or have you heard of any instances where people have wanted to take into account anything with regards to the interaction between that kind of top placed solar array and all the various equipment that might be on the cell tower? So basically, not so much radio interference, but things like transient voltage or general electrical interference if, the electrical communication devices on the top of the tower were powerful enough and the array was placed close enough. Is that a consideration that people should look out for?
Actually, a good question. No, it's the opposite. It's usually the electronics people that have an issue with our stuff.
Huh.
And again, because to be honest, the solar module doesn't care, and neither is the battery. And to be honest, the battery
Okay.
is because you have these two large lead plates is nothing but a giant capacitor, and it absorbs transients. It's a giant filter,
Mm-hmm.
basically.
Mm-hmm.
So the only thing it might possibly affect is the charge controllers, and they're all pretty hardened anyway, so that's not an issue. It's usually the
Mm-hmm.
opposite. It's usually these charge controllers
Okay.
sometimes can sometimes unfortunately create a noise on those lines. That's why you'll see some of the pulse width modulated ones actually have an option to turn the pulse width modulation off and go back into a on-off type charge controller. Because the frequency of that pulse width modulation can sometimes be interference for the radio equipment, the antennas and stuff like that. So it's actually the opposite. It doesn't affect our stuff. Our stuff can sometimes potentially affect the communication stuff. And again, there are options to defeat that, and I would recommend you go to some of our controller webinars where we talk about that. The one thing I would say, though, with regards to that equipment, though, is be careful again of the antennas and shading. I know we talked about the stacked modules shading each other on a pole. You can do the same thing with an antenna. If you put an antenna or any other piece of equipment directly above a solar module, you have exactly the same problem. If that sun is directly overhead, it's going to shade it. So it just depends on how big an object it is, where it is in the pole, and where the angle of the sun is. And again, I have to pull out my trig calculator and do a whole bunch of trigonometry to figure it out, but I can figure out what that distance needs to be to prevent the shading from occurring. At some point, you do get too high. Again, if you were directly overhead, it's basically 90 degrees. There will be shading, period. There's no way around it. But we don't have that in the U.S. You'd have to be further south to get to. I think you have to be like south of Florida, I guess, to get to a point where the sun can get directly overhead. I guess it's the Tropic of Cancer or something like that. You basically to be within the two Tropic of Capricorn, Tropic of Cancer, whatever it is. You have to be within those two to have that situation. Otherwise, we're north of that, so the array is never going to be directly overhead. It's going to be at a 70 or 80 degree angle, something like that. So there's got to be some point of a distance at which you will not have shading. The problem is that point 10 feet or 100 feet? If it ends up being 100 feet, you're probably going to have a problem. It just depends on the pole. But anyway, I've probably talked more about that than I needed to at this point.
Oh, no, it's helpful. One other quick question. I think specifically within the context of these arrays on a tower that might have electrical considerations nearby, is the solar equipment grounded separately from perhaps other pole-mounted equipment like the enclosure, or does it not matter in this application?
I'll refer you back to some of our other webinars on grounding, but I just want to clarify, there are two different types of grounds. There's an electrical ground and there's a mechanical ground. So if you were actually going to ground the solar array, the frames and structure through the pole, that's okay. That's not a problem. Mechanical grounds don't matter. That's okay. The electrical ground is another story, and I would recommend that that electrical ground get connected to the ground system at one point and one point only. And if you do that, there should
Okay,
not be any issues. Okay, so again, I want to
okay,
split that up into a
that's
mechanical ground
helpful.
and an electrical ground. Mechanical ground doesn't matter. Electrical ground, yes, it does, and there should be one point and one point only, and that should be at the ground system itself at one point down on the ground somewhere near the ground rod or whatever that is.
Thanks, Rob. Appreciate that. Okay, I think we're a couple minutes over. I will give folks just a few more moments if there are any other last minute questions. Again, this webinar will be posted on our website within about a day, and the email notification that will go out 24 hours after from now will contain the link to that. Of course, if you have any other questions or issues, you can always email me directly.
Okay, well, thank you everybody for joining us today. I think our next webinar coming up is on solar wind hybrids again. We're going to repeat that one. We did that one, I think, almost 9 months ago now or so. So we're going to repeat that one. And then we have some more we're working on. I apologize, we don't have those up yet. We have some coming up, though. I think we're probably going to be doing fuel cells rather soon. So that'll probably be one of the topics. A lot of people have been asking about that one. So we're probably going to do that one soon. And I think we're working on some other stuff, too. As always, if you've got something specific you'd like us to do, please feel free to send us an email and let us know. Be happy to cover any topics you might have. If it's something we've done before, be happy to repeat it as well, too. We do try to repeat these every so often, maybe about once a year or so. So if you've got something you'd like us to repeat, we'd be happy to do that.
All right. Thank you, everybody. Thank you, Rob.
Okay, thank you, everyone. Have a good day.
All right. Bye.